In this research, we asked the question, if there's a right font for everyone, how can we help them choose? While we know font influences reading speed, the current reading interface does not help us find our faster reading fonts. Instead, the commonly seen font selector presents long and alphabetically sorted list of fonts with very limited guidance. Typographers we have worked with often champion the importance of personalizing font choices. Based on interviews with them, we found that there may not be a one-size-fits-all font. In fact, different users may read faster in different fonts based on their age, self-rated reading speed, and other characteristics as a reader. Additionally, we have commonly observed in other studies that readers are often not able to select their fastest fonts simply by preference. So, how can we recommend a faster font to the reader? We explored the use of machine learning to help accomplish this task. Today, I will walk you through the findings from our endeavor to build a personalized recommender for faster fonts. We start by identifying features that may influence reading speed, because these features can help us estimate reading speed for individuals. Based on interviews with typographers and literature reviews, we identified a suite of font and reader characteristics. We collect font data through a custom-built web application and the user data from our readability studies. After experimenting with a wide variety of models and structures, we adopted LambdaMART to help sort fonts based on these input features. To train an ML model, like our recommender, we need to collect training data. Our training data comes from the readability study run on 252 paid crowd workers. During the study, they performed reading studies that included font preference test, reading speed, and comprehension tests. Our objective is not to differentiate the bad from the good fonts, but rather to select the personalized fastest fonts. Therefore, we focus on fonts that are considered prevalent, diverse, and readable to begin with. During the readability study, we asked participants to perform the various tests in all age fonts shown on the right. In the study, we again find that the participants were unable to identify their fastest fonts simply based on their own preference. In fact, participants preferred fonts with larger X height and larger widths, such as Meriwether and Poppins. However, Georgia and Arial are more often their fastest fonts, again showing the importance of supporting reader with font recommendation. Now, we look at the predictions made by our font recommender, FontMART. We find that it does a much better job than the users to recover the ground truth distribution of the fastest fonts. We've evaluated our personalized font recommendation against various baselines. Comparing to them, we find that our personalized recommendation helped participants read faster by 14 to 26 words per minute. That's equivalent to 2 or more additional letter pages read per hour. However, on average, the ground truth fastest font is still 46 words per minute faster than our recommended font. This shows the possibility to improve our recommendation further with even more training data. Recall that at the moment, we only have 252 participants in our study dataset. We can also dive deeper to understand why our model works well. As we expected, a combination of reader and font information helps support accurate model prediction. Among all the factors considered, age plays the largest role. This is a pattern that repeatedly came up during our interview with typographers as well. When we look at the font recommendation by quartiles of age, we find that Georgia is recommended more often for the older users. Arial generally works well across age groups, and Poppins work particularly well for participants between the age of 19 and 25. Based on the takeaway from the model, in the absence of fully personalized model, we can still provide a recommendation by age cohort. Therefore, even though some developers may not be able to fully implement this personalization model, our insight can still be implemented easily using a rule-based system.